Today's lesson is properties of real numbers. Your guiding questions: what are the subsets of the real numbers? And guiding question 2, what do the properties of real numbers represent? And are there any exceptions? Keep these in mind as you're going through the lesson. The essential understanding states that a set of real numbers has several special subsets that are related in particular ways. The subsets of the real numbers are the rational numbers and irrational numbers that form together to make the set of the real numbers. Rational numbers plus the irrational numbers equal the set of real numbers. This diagram shows how the subsets of the real numbers are related. We have the natural numbers, which are counting numbers, 1, 2, 3, and so on. We have our whole numbers, which are the natural numbers, and then a 0 is added in. We have our integers, which are the natural numbers, their opposites, and 0. We have our rational numbers, which if you look down here, says they're any number that you can write as a quotient of integers, which means a fraction, where b isn't 0. It includes terminating decimals and repeating decimals. And then we have our irrational numbers. And our irrational numbers are the opposite of our rational numbers. Opposite of our rational numbers. Their decimal representations neither terminate or repeat, and they cannot be written as a fraction. Looking at this problem 1, classifying a variable. Your school is sponsoring a charity race. Which set of numbers best describes the number of people P who participate in the race? So we want to pick which set of numbers best describes it. Since the number of people is going to be like a counting number, 1 people, 2 people, 3, 4, and so on, our best answer is A, our natural numbers. Now I'd like for you to do problem 1. I got it. Our next thing we're going to look at is graphing numbers on the number line. We take a number line. We want to put the numbers where they belong on there. Sometimes we might need to change the form of a number from, say, the square root to its decimal form in order to write it down. Or we may want to think of it in terms of fractions like they did right here. It's just whatever works so that you get in your head the best placement of where that number falls on the number line. For the guided problem number 2, I want you to draw a number line and put those numbers where they belong. Now we're going to look at ordering real numbers. It involves a comparison. We want to compare both numbers to the square root of 16. To do that, again, you may want to change the forms to where they're both the same form. Change to the same form. And then you're able to make your comparison. Now I'd like for you to do got it number 3. Now we're going to look at our properties of real numbers. Before we look in the box, our take note box there, let's look at a couple of words first. The first one, the opposite or additive inverse of any number A is the opposite of A. And if we look at our examples, 12 plus negative 12 equals 0, and negative 7 plus 7 equals 0. So 12 and negative 12 are additive inverses, and negative 7 and 7 are additive inverses. The reciprocal or multiplicative inverse of any non-zero number a is its reciprocal, 1 over a. So that means when we multiply them together, we get the multiplicative identity, which is 1. So we have 8 times 1/8 equals 1. So 8 and 1/8 are reciprocals or multiplicative inverses, as are negative 5 and negative 1/5. They are also reciprocals or multiplicative inverses. In our box here, we have our properties of the real numbers. The properties of the real numbers work for addition and multiplication. Closure just says that under addition and multiplication, if you add two real numbers, you get a real number. If you multiply two numbers, you get a real number. The commutative property deals with order. The order of the numbers doesn't matter. Adding two numbers together will be the same whichever order you do it, as will multiplying. The associative property has to do with grouping, where I place my parentheses. Again, it says that the way we group them doesn't matter for addition and for multiplication. The identity property says that 0 is the additive identity, so that means if I add 0 to a number, I get the same number back. The multiplicative identity is 1, which means if I multiply any number by 1, I get that number back. The inverse property states any number plus its opposite equals 0, which again is our additive identity. And our multiplication inverse property says if I multiply two inverses together, I get 1, which is our multiplicative identity. And then our last property is our distributive property, which says that if I multiply a number by a quantity or a sum, I take the number and multiply it by each number that's in the quantity or the sum. And that is our distributive property. Looking here at problem 4, they ask us to decide which property each equation illustrates. When you're doing that, follow these steps over here in our plan box. Determine whether it uses addition or multiplication, and then look for orders or regroups, or whether it uses an identity. So if I look at A, I'm dealing with multiplication. I have inverses, negative 2/3 and negative 3/2 are inverses and they equal 1, so I have my inverse property of multiplication. Example B, I have 3 times 4 times 5 equals 4 times 3 times 5. My parentheses stay with the first set of numbers, but inside those parentheses, the order of the numbers changed. So that would be our commutative property of multiplication. Now I'd like for you to do the Got It Problems 4.